Hi guys, today we are working on section 3.4 exponential and logarithmic equations, day 2. Specifically, we're going to be talking about logarithmic equations. So, our extraneous solutions. Any value of x that produces the logarithm of a negative number or the logarithm of 0 is extraneous. The value should be excluded. Excluded means left out from the solution set. Okay, so for our first example, we have the log base 4 of the argument 5 plus x equals 3. To solve this, we are going to use the definition of a logarithm. 4 to the 3rd power equals 5 plus x. We are going to evaluate, so 4 times 4 makes 16, times another 4 makes 64. If you're not real comfortable with your arithmetic, you're using a calculator. Is equal to 5 plus x. To solve for x, we're subtracting 5 from both sides. And we get 59 equals x. Again, with our logarithmic equations, we always want to be checking our answers to make sure that we didn't find an extraneous solution. So I am just going to plug this in. Log base 4 of 5 plus 59, is that equal to 3? Okay, so let's say that you are not super comfortable with your logarithms and you decide that you're going to use your calculator. So hopefully you would realize that this is log of 5 plus 59 is 64. And we know we don't have log base 4 in our calculator, so we're going to do the common log of 4. And we want to see if that's equal to 3. So I am grabbing my calculator. I'm going to try log of 64 divided by log of 4, and I get 3. Okay, so I know that I got the correct answer, and my answer is x equals 59. For part B, right, this is more complicated. We are going to use the properties of logs to simplify. You want to notice that both of the log expressions have the same base. They're being subtracted, so that means we can condense our log expression to be the log with the same base 4 of the quotient of the first argument as the numerator and the second argument as the denominator. Okay, common mistake here is that people set 5x minus 1 over x plus 7 equal to 0. That's not what this log statement is saying. You still have to use the definition of a log. The definition of a log says that 4 to the 0 power is equal to 5x minus 1 over x plus 7. So now we're evaluating again. 4 to the 0 is 1, is equal to 5x minus 1 over x plus 7. Okay, I always think of this whenever I see a proportion, okay, or a fraction, a rational algebraic expression, I cross multiply. So I think about my 1 as 1 over 1. I multiply and I cross multiply. 1 times x plus 7 is going to be x plus 7. And 1 times 5x minus 1 is going to be 5x minus 1. And now we're just solving this equation. I'm going to subtract 5x from both sides. So I'm going to get negative 4x. And I'm going to subtract 7 from both sides. I'm going to get negative 8. Okay, I'm hoping by now you don't need me to write out all of these steps. If you do need to write out all those steps, do it, pause the tape, do it in your own notes. We're subtracting both sides by negative 4, and we get x equals 2. Okay, again, we want to check So I want to see if log base 4, I'm going to do some mental math to try to save myself some time. 5 times 2 is 10, minus 1 is 9. So log base 4 of 9 minus log base 4 of 2 plus 7 is 9. Is that equal to 0? If I have the log base 4 of 9 and I subtract log base 4 of 9, I will have 0, so I know I have the correct answer. Moving on to part C. So what you want to do is you want to simplify the left side and then simplify the right side. If you look at this, right, log base 5 of 2x plus 3, there's nothing we can do to simplify on that side. So I'm just writing that down again. On the right-hand side, I'd be much better at this if I knew my right from my left. Quickly, I am going to rewrite this argument, okay, just to save myself some time. Instead of having 4 log 5 of 3, I'm going to have log base 5 of 3 to the 4th. Okay, and I also noticed that 3 to the 4th is 81. Not 3 times 3 is 9. 9 times 9 would be 81. So now I'm going to use the product property, and I'm going to see that this has the same base 5, and because these are added together, I'm going to multiply 11 times 81. Okay, and I am going to find with my calculator that 11 times 81 is 891. Sorry, it's hard to see in the light. Okay, so I'm going to rewrite this as 891. Okay, but now I have log expressions on both sides of the equation to the same base. So that means that their arguments must be equal to each other. Okay, so if the log expression is the same to the same base, then the arguments can be set equal together. So I have 2x plus 3 equals 891. I'm going to subtract 3 from both sides. I'm going to get 2x is equal to 888. And then I'm going to divide both sides by 2 to get x equals 444. So again, I want to check. So I want to see if log base 5, 444 times 2 would be 888, plus 3 would be 891. And we already figured out that our right-hand side is equal to 891. So this is going to check. We know we have the correct answer. Let's move on to letter D. So again, we have the same base, and this time we have a sum. So we're going to use the product property of logarithms. So we are going to keep the base, and in the argument, we are going to multiply those two arguments. Okay, so now we have a single logarithm to a constant, so we can use the definition of a logarithm. I'm going to start doing some of this in my head when I can. 2 to the third, okay, 2 to the third is 8, and that's going to be equal to x times x, which is going to be x squared, and x times 2 is plus 2x. Okay, if you can go to your head, that's great. If you couldn't, what I just did is 2 to the third is equal to x times x plus 2. I use the definition of the logarithm. 2 to the third is equal to the argument. And the 8 equals x squared plus 2x was just simplifying both of those in my head. So now I want to set this equal to 0. So I am subtracting 8 on both sides. Now I need to think of two numbers that multiply to -8 and add to 2. I'll give you a second to think about that as I write. I get my two numbers as x plus 4 and x minus 2. Okay, so real quick, 4 times -2 is going to give me -8. -2x plus 4x gives me the 2x. So my solutions here are x equals -4 or x equals 2. So as soon as I go in to plug in -4, I am going to get log, so my check of x equals -4. I am going to get log base 2 of -4. And as soon as I see that argument is negative, I should know that this is an extraneous solution. Okay? Because remember, you cannot have an argument that's negative. Okay? So right away I see that -4 is not a solution. So now I'm going to check x equals 2. And I want to see if log base 2 to the 2, log base 2 of 2, plus log base 2 of 2 plus 2 is 4, if that's equal to 3. Oh, I'm sorry, I went off the page. So all I did here was I substituted in 2 for x in my original equation. Log base 2 of 2 is 1. Log base 2 of 4 is 2. And 1 plus 2 is 3, so it checks. My solution is x equals 2. Okay, -4 is an extraneous solution. I can't have a negative in my argument for a log. Okay, well, let's flip on to the back side.